over 7 years, working on the development of real-time BGP monitoring systems in collaboration with Curator, Radar team. And he began his career as R&D developer. He then transitioned into product management, focusing on creating monitoring solutions that serve community and large-scale enterprises. Thank you, Arvind.
Okay. Thank you. Hello, everyone. It will my first speech in English. So I have paper backup. Okay. First slide. My name is Ivan Potapov. I work in the radar team of Curator Labs. One year ago, my colleague Eugene Bogomazov has talked about rolling out our RFC, which should to protect against road leak. This autumn, we rolled out a new website for the community and the functionality of our site, which help network engineers with connectivity analysis. So, what are we going to talk about? Firstly, we'll review the approach to modeling the topology of the internet. Secondly, we will briefly talk about some popular services based on BGP data. After that, we will move on to the review of our site and talk about its improvement. So, when I speak about connectivity, I mean level 3 connectivity, IP connectivity. So, where can we get information about IP connectivity? Of course, the first option that comes to mind is looking glasses. Many large operators have these services, but looking glasses have routing information only from one observation points, only one routing table. However, there are BGP collectors. BGP collectors are storehouse of information about routing. How do they work? BGP collectors collect routing tables from hundreds of routing tables in various countries. As a result, a significant data set are accumulated. Also, there are public BGP collectors and private ones. Example of public BGP collector is RIPE-NCC, European BGP collector, Road Views, and Packet Clearinghouse from America. Also, there are private ones like collector of Hurricane Electrics and like our Curator Radar collectors, etc. What should we do with this information after keeping? We can try to build information. We can try to build a model of the internet in a graph. How do we do this? First of all, we have to parse data about BGP updates from our collector. Usually, BGP updates keeps in MRT format, and we can extract from this format information about prefixes, information about ASPasses, information about communities, and from ASPasses we can extract origin autonomous system, and we can extract links between autonomous system. Next step is building a graph from these links. It will be a connectivity graph. After building the graph, we can try to mark internet networks topology. The topology represents IS relationship between autonomous system. When I speak about relationship, I mean provider to customer relationship, peer-to-peer relationship, or sibling relationship. Defining the relationship between different speakers is a mathematical problem. The methods for solving problem were formulated in the works of Gao and Rexford in 2001. Keeping data, storing and parse MRT dumps, building a graph, making a relationship can be challenging. But we are often need quick results to solve our problem. Fortunately, there are a few services that provide analytical information based on BGP data. Many of you probably already familiar with these services. It is RIPE-NCC widgets, Hurricane Electric website, BGP tools, and our service, Curator Radar. Each of them have pros and cons. For example, RIPE offers useful widgets, and one such widget is BGP Play, which provides great historical data about as path and about changing in routing. But widget has an intuitive interface and some delays in data, and making it unsuitable for quick investigation of connectivity incidents. Hurricane Electric also has a lot of information about BGP, but not also about BGP. Hurricane Electric has a lot of useful looking glass services on its routers. Also, it has good tools for tracing. Our system also one of BGP-based analytical system, and we provide service for community for around 10 years. And let me tell about our system. But before start, I would like to ask who already know about our service. Well, nice to meet some hands. Thank you. And one another thing is QR codes. I will provide QR codes, and you can see the page when I show you. Just scan and go. First thing, it is our connectivity graph. Our graph represents information about the propagation of prefix from origin AS to the target ASs. And what new information can we add for this graph? We can overlay each link from as path with our relationship, because we have our own autonomous system relationship model. And we have a colored relationship between autonomous systems, and green is relationship from customer to provider. Orange is relationship between peerings, and blue is relationship from provider to customers. And sometimes pink happens if we don't know relationship between two autonomous systems, or it is a sibling relationship. If you would like to see propagation of prefix in your region, you can select your country near target autonomous system and see regional propagation. For example, you can see a propagation of your prefix in South Africa. Also, you can add your target autonomous system, and we will try to show as path from origin to your autonomous system. It looks like interactive multi-looking glass, but it depends from count of our observation point in country, and sometimes our graph is empty. It happens because sometimes we haven't routes from observation points to origin autonomous system, which announce prefix. But here we can try to predict as path based on our historical data about BGP links and based on our relationship model. And we add a switcher, and we can switch, turn off switch, and predict the route. And again, it is not real route, it is predicted. Next thing is prefixes tab. We spoke about propagation of one prefix. But usually autonomous systems have a lot of prefixes, and we need a tab for managing of these prefixes. And at prefixes tab you can see information about H prefix which was announced by autonomous system. Also at this tab you can see a history about prefix security object, a history about appear and disappear route object, appear, disappear RPKI row object. Also you can see a history about appearing and disappearing announce, and you can export the data from this tab. Also, almost each autonomous system have BGP neighbors, and we have a special tab with BGP neighbors where you can see providers, customers, and peerings of your autonomous system. This slide shows an example of Cloudflare's client growth during the pandemic. Next thing is information about ping, about internet exchanges. Sorry. For many years, we did not provide information about traffic exchange points. However, last year, we began showing information from PingDB. PingDB is an open database containing information about networks, organization, traffic exchange point, and so on. I think all already familiar with this database, and we did a special tab with information about traffic exchanges where your autonomous system is present. It is a simple tab. Next tab will be more interesting. It is peering tab. At this tab we added a new column about common with common I-axis. And this column presents information about I-axis where both speakers are present. How do we do this? We take a peer-to-peer link between two speakers' ISs. For each speakers, we determine the presence of the internet exchange according to PingDB. If both are on the same IX and the IX name to our common IX list. Okay, but I must repeat that this data based only on PingDB data, and presence on IX does not mean that there is a traffic. Next thing, it is about network planning. Let's imagine then you are owner of a large network, and you want to grow your business, and to do this you have to expand your network. The question arises, where to place new point of presence? How do we approach to this? We can measure delays. For example, we can use RIPE Atlas probes and identify the countries where these delays are at maximum. Also, a number of potential users of our service is important. And for example, let's choose India and say We don't know anything about this country, but we are planning a new connection with the best providers in this country. And the question then arises. Who is the best provider in this market? Without fundamental knowledge, the task may seem complicated. I mean knowledge based on BGP data. And what approaches are possible to solve this problem? For example, you can try to build a rating and consider the top of autonomous system from this rating. But there is one problem. The providers may be from desired country, while its client could be from another country. Because we aim to reach as many local providers as possible, we need to separate apple from oranges or flies from food. And recognizing this, last year we launched a new ratings category known as regional ratings, where we recalculated global metrics to regional metrics. And now we have metrics like the average number of hops, the count of local providers, count of local customers, the size of local customers con, etc. And so now we have separated ratings for each country. How do you use it? For using this, we developed a special service that helps you understand the ISP market in the selected country, and you can just select metrics. After that, select country, filter non-local players, and after that you will see the list of candidates to connecting the list of best autonomous system by these metrics. Also, we have a lot of another updates, not relates with connectivity. Also, we have some new services, and we can discuss them afterwards if you want. Also, we have a Twitter channel, and in this Twitter channel, we published information about global BGP incidents like hijack, like root leaks. For example, yesterday was global incidents. And that's all, I think. Thank you.
Thank you, Ivan. Do we have questions?
Please speak slowly. I have language barrier.
Hi, Nishal Gobardhan, Packet Clearinghouse. I'm curious about your method for collection, the data collection methods. Are you receiving these via multi-hop external BGP sessions? Do you have a POP in South Africa?
Repeat that.
Point of presence. Sorry, I shouldn't say.
Are you doing multi-hop for BGP?
Yes, of course. Every owner of autonomous system can do multi-hop with our peering collector, and we have instruction for doing this. I can send you.
And so to be clear, you currently collect data out of South Africa.
Okay.
You have
yes, we already have BGP multi-hop session with some providers in South Africa, and we collect this data in our collector. I understand you? No?
Yeah, that's kind of the start where I'm going. I'm worried that this is going to turn into a lightning talk at the microphone. I'm curious about, what's your collection methodology? Do you just reach out to the 3 largest operators in the region and say, hey, ISP 1, 2, and 3 in South Africa, can I get external BGP from you? Do you actively source collection points at things like internet exchanges? Do you reach out to, because that didn't come across clearly to me.
If you spoke about collection methodology, you mean What do you mean? You mean what target autonomous system where we, which I show on the slide? We have ratings of biggest autonomous system for each country, and when I show graph of propagation, we stopped showing graph on the biggest internet service providers from South Africa based on our rating. And if we have a session with one of these providers or its customer, we will have route to target prefix.
I'm curious because obviously that gives you a nuanced view of the story from BGP. Other mechanisms for data collection, for example, are operators that, or route collection agencies that attach themselves to internet exchanges where you can get data directly off a peer off an internet exchange, right?
About internet exchanges, it's good.
And there's multiple advantages from that because, for example, if you're looking at things like who's propagating invalids, both of the exchange operators in South Africa reject invalids, RPKI invalids. So you wouldn't see that necessarily. There are some operators that are more clueful than others that reject invalids. So I'm just curious as to how you collect your data, but I won't keep you here. I'll catch you in the corridor and we can talk more there. Thank you.
Okay.
Alan?
Hi, my name's Alan Naveen. I met Ivan at one of the NOGs in the last few years, and he's probably collected